All right, we are in chapter 2, and this is going to be section 4 and 5. It's solving quadratic equations by completing the square and solving quadratic equations by using the quadratic formula. So we're going to do both in this situation. So first of all, we'll just take a look at the screen. So this is what it will look like when we first open it. With the exception of the fact that, you guys will have a due date on your screen. I don't get a due date on my teacher preview. It will always show you the number of attempts you have, and I'm on attempt number 1 of unlimited attempts. This means I can submit my assignments as many times as I would like and keep coming back and retrying them. It does not mean that it's going to reset it and make you do all of the questions. It's only the questions that you either have not answered or you have gotten incorrect. This is the number of questions on this particular assignment, which is 6. It'll be anywhere from 1 to 10 questions, depending on how many were available for the sections. And grading policy is always best score, meaning, whichever attempt is the best is the one you get to keep. And our partial credit is enabled. So if I answer 1 of 6 questions, I get credit for my 1 question. Down here it says, once you start your homework, you must finish it before you can work on anything else. So what that means is if I click start here, down in the bottom right-hand corner of your screen, you will now see a submit assignment button. So no matter what, when I want to leave this screen now, you have to click the submit assignment button. Otherwise, it will lock out every other assignment in the program. So that's definitely not a good idea. We want to click that button. It also lets your teacher know that you've been working on this assignment and how many you've worked on. So that's very important. You will see 3 buttons on the side here, on the right side. You may also see a calculator button from time to time. So the first one is explanation. It tells you you're going to lose your question attempt because it's going to give you the solution to this question. Not an example, this question exactly. So it's not going to give you the answer and then have you, come and type it in. You can also click on example. This one just gives you a general example of what you're working on. So this is all about completing the square. And this is a very nice thing because you can come in here really quick and say, okay, this is what I need to do to complete the square. So it says to find what number to add 2y squared plus 4y to get a perfect square, we do the following. Find half of the coefficient y. So the coefficient of y is the number right in front of y here. So you find half of it, and then you square that number. And that's what you add on to the end. So this is actually exactly what we're going to do in this next step. If you've read the examples, and you can get more than one if you click on here, it'll give you another example, and it'll keep giving you more. And you're still not sure how to do this exact problem, you can click on that explanation button to see it. It'll just give you the red X, and you have to come in on another attempt to actually get credit for this question. You can also message your teacher from the system. It will attach this question to your message so we know exactly where to help you. Okay, let's go ahead and get started on this one. So just like we read in the example there, to do this one, to complete the square, what we want to do is we want to take half of that coefficient of w, in this case, which is 14. So I'm going to take half, and then I'm going to square that, and I'm going to say 49. And that's simply what I add on to the end here is 49. And that's completing that pattern, that completing the square. So we are good to go on that guy. So this is just about pattern recognition for some of this stuff, and it's a quick way to solve things as well. So solve the quadratic equation by completing the square. First, choose the appropriate form. So you can see we have 2 forms here. We have to choose, is it addition or is it subtraction? So if it's all addition, it's going to be addition. If there's a subtraction sign in here, and it will be this middle one here, then that's when we choose subtraction here. So we want to do, this one's a little different, and I'm going to go ahead and click on example here, and you can see there's a calculator button also, so it did pop up. If I click on example, this one's a little different because it has an equal on it. The last one was just an expression. It didn't have the equal to. So now what we want to do is we want to get it in this form here, meaning we want just x squared plus 4x on one side, and we want the regular constant on the other side. And that way, when we complete the square, we can actually see, we can put it right into this square form here. It makes it very, very easy or very quick to put it into this format if we do this correctly. We're still going to take half of the middle term and add it, but we add it to both sides. So I'm going to exit out of this really quick. And once we get down here, we're going to actually solve this by taking the square root of both sides. So if I take this and I go x squared plus 10x, and I want to subtract 19 over to this side, so I'm going to have minus 19. And I left this open on purpose. I'm going to have plus a number, like this. So this just shows me I have some blanks to fill in. So I want half of that middle term, and then squared. So I'm going to have 25 and 25. Well, since this is a square, I know I can have x plus the square root. So I'm taking the square root of the first and the square root of the last, and then I'm squaring that. So that's why they have it in this form already. Because if we recognize this pattern, we can immediately put it into the factor form, which is x plus 5 squared, equals, and these guys we just want to combine these. So I have 19 negative plus 25 positive, so I get 6. So this is what I want to type in here is 5 and 6. I'm not going to fill this one in because I'm only using this form. So now down here, they actually want us to figure out what this answer is. So I'm going to use the square root property. I'm going to take the square root of both sides. Well, the square root of this one, remember this is x plus 5 times x plus 5. That's what squared means. So I just have x plus 5 on this side equals, it's going to be plus or minus the square root of 6. Because I can have positive square root of 6 times positive square root of 6, and I'll get the same answer as negative square root of 6 times negative square root of 6. So whenever you take the square root like that, you have to do positive and negative. So I have x equals, sorry, I jumped ahead there without saying what I was doing. I'm going to subtract 5 from both sides. Now I'm saying what I'm doing. So I'm going to have x equals negative 5 plus or minus the square root of 6. So I need to do this twice. And I'm going to go ahead and do this on the calculator here so you can see it. So I have negative 5 plus the square root of 6 equals, here's my first decimal, and they want us rounded to the nearest hundredth. So there's my hundredth right there. Or here, I'll highlight these past it. So I want to make sure that's a 0, so that just means they're going to round down. So it's going to be negative 2.55, comma, I'm also going to have another one, so I'm going to have negative 5 minus the square root of 6, because I did plus, now I have to do minus, equals, and here we have it again. Now if I go to hundredth, that's a 9 on my, right past my hundredth there. So that means this is also going to drop off, but this is going to turn into a 5, right? I have to make sure I round correctly, because yes, I will get marked wrong if I do not correctly round. So let's check that. And we are good to go there, yay! So this is just completing the square in a slightly different way. So that top one, we just had to figure out what am I adding. But then once I'm given an equation, I have to move the constant over to the other side. And I just have to remember I'm adding that to both sides. And then I'm going to take the square root to actually solve. All right, let's erase this really quick. So we're going to use the quadratic formula. Again, if you don't know the quadratic formula, this is where you would want to click on this explanation button, because it's going to give it to us in here. And we want to also understand the standard form, the equation we're looking at. So this is ax squared plus bx plus c equals 0. So this is the form that we should be looking at when we're doing this. And then the quadratic formula is x equals negative b plus or minus b squared minus 4ac divided by 2a. And this seems, I know with some students they get a little bit overwhelmed because it seems a little bigger. All we're doing is taking some numbers and plugging them in. So if my coefficient in front of x is this b, that's what the b's gets replaced with. And then the same thing with a, it's the coefficient in front of x squared. c is my constant at the end. So we're just replacing them, and we're working this out to the end. And we will have two answers just like this. Be careful about actually completing this one, because seeing as I can see these here, these square root options, they don't want us to round anything. They're not telling me to round anything here. So that tells me that they're looking for more of an exact answer, which means I will have a square root, unless by chance I end up with a perfect square. So let's go ahead and practice this. 2x squared minus 5x minus 1 equals 0. I have a, b, c. So I'm going to go x equals negative b. So don't get rid of this negative. It's negative and then another negative 5 because b is negative 5 plus or minus negative 5 squared minus 4. This is always going to be 4 times a, which is 2, times c, which is negative 1 over 2 times a. All right, so let's reduce this. So negative, negative, that's a positive 5. Plus or minus, we get 5 squared is 25. Negative 4 times 2 is negative 8 times negative 1 is positive 8 over 4. And then 5 plus or minus. So we have 25 plus 8, which is 33. So that's definitely not going to be a square there, over 4. So there's really nothing I can reduce here. 5 and 4 don't reduce into each other. 33 doesn't have any squares that I can pull out of there. So I just need to type this in. Remember, this is two answers. I have 5 plus the square root of 33, and I should have put this into a fraction, so I'm going to highlight the whole thing. Click fraction over 4, and then I'm going to hit comma and do the same thing. It's going to be 5 minus the square root of 33. So I need to separate these out because there is no plus minus button here, right? So I have to type them both in this way. Plus minus, when we do it this way, it's kind of a quick way to show that there's two answers. But a lot of the time you have to type it in separately on the program. Alrighty, so a couple more of these. Try not to have to rewrite all of this. So use the quadratic formula to solve for x. So we have 6x squared minus 8x equals 1. Ooh, we want it to equal 0, so I need to subtract that 1 to the left side there. So if I subtract it on the right side and subtract it on the left side, I end up with 0 there and then minus 1 over here. So now I have a, b, c. And I can start plugging this in again. So it's negative b, so negative negative 8, plus or minus the square root of b squared minus 4a c over 2 times a. So again, I'm just filling in a whole lot of letters there. I know a whole lot of variables, but I'm filling them in, and now we have to go through and work them out here. So negative negative 8 is actually positive 8, plus or minus 8 squared is 64. Negative 4 times 6 is negative 24 times negative 1 is positive 24 over 2 times 6 is 12. So 8 plus or minus, let's see, we have 64 plus 24, and that gets us 88 over 12. All right. The next part here does say round to the nearest hundredth. So they do not want me to leave it in radical form. So I'm going to come back to my calculator here, and I'm going to go 8, if it'll let me, 8 plus the square root of 88. And I'm going to go ahead and hit equals, because if I don't put this in parentheses, if I just hit divided by, it's going to do something funny there. So if I hit equals and then divided by 12, then it'll show up correctly. And I want to go to 100th, so that's the 44 there, but this next number is an 8. That's 5 or bigger, so it's actually going to be 1.45 And then I'm going to do 8 minus the square root of 88 equals, and then divide by 12, just so that, again, I don't have to deal with that issue. The hundredth would be the 11, but that next number is a 5, so it's going to be negative 0.12. Check. All right. And this is definitely necessary to use this formula once you get to these types of parabolas where you don't have the nice integer answers anymore. I can't just factor this the way we were before, where we had, you know, the two parentheses like this, and I was saying, breaking it apart into, you know, what numbers of 6 and 1 can multiply together to get the correct beginning and end number, but add to get 8. I'm not going to be able to do that when I have to have these decimals that are going down to the hundredth. That would just be impossibly, you know, time consuming there to even try to do that once you start to get to decimals, because we're talking about hundreds of numbers here if we're going down to hundredths. So we don't want to have to do that once we get to this point. We want to be able to just plug it into a formula now that we understand the idea of factoring. Okay, so now we want to look very specifically at a part of the quadratic formula, and I'm going to go ahead and switch over. Oops, I didn't mean to click on that guy. Switch over to red here. We're going to look at this piece under the square root sign. This is called the discriminant. And why we want to look at this one is it very quickly tells us whether or not our answer is going to be 2 real solutions, which if we're looking at a coordinate grid here, 2 real solutions means it looks something like this, where I have it crossing the x-axis twice. If we have 1 real solution, it means that it was kind of touching right there on top of, so it's just right on the x-axis. And these could also be negative. They can open down as well. If we have one that's not touching the x-axis at all, so I'm showing you the downward one, this would be imaginary roots. And I think they only want us to identify 2 or 0, or 2, 1, or 0 for real roots, I'm pretty sure is how they want us to identify this. So we either have 2 real solutions, which is this first one I drew, 1 real solution, which is the second one I drew, or no real solutions, which is this one down here that's not on the graph at all. And that means that we ended up with a negative number here. So if I kind of back this up a little bit, if it equals a positive number, basically, positive number. So if the discriminant equals a positive number, then you have 2 real. If it equals 0, then you have 1 real. If it's a negative number, and remember that means that this is under a square root sign. So if we have a negative number under a square root sign, just like we were learning a few weeks ago, that's an imaginary number because we can't really have the square root of a negative number. It doesn't make sense if we think about how did it get there. It would have to be a number times itself, which is either both positive or both negative. You can't end up with a negative number. So that's why we have this imaginary number to deal with that situation. But in this case, we're just saying that that's 0 real answers. So we're going to go through and we're going to solve this. And I'll switch up. Let's see. We'll go with orange, I guess, here. Or you know what? I'll go with bright blue. Why not? So all we're going to do is the discriminant on this one. X squared plus 7x minus 1 equals 0. So we have A, B, C. So I still have to look at A, B, C because they're all in here. But now I'm going to go B squared minus 4 times A times C. So all I care about is this answer here. So that's 49. Negative 4 times 2 is positive 8 times negative 1 is negative 8. So now I have positive 41. So that's a positive number, and I want to type this in, positive 41. And since it's a positive number, I'm going to have 2 real solutions like that. I can click check. So there's just a very quick way to see how many solutions. No matter what, I actually know I'm always going to have 2 solutions to this, but if it was a negative number, they just wouldn't be real solutions. And if it's a 0, it actually means that it'll be a double root. So that's why we only have 1 actually shown, and we can actually see that when we work it out. But it just means that it's a double root. Okay, we have one more of these guys. Okay, a ball is thrown from an initial height of 5 feet with an initial upward velocity of 27 feet per second. The ball's height, h in feet, after t seconds is given by the following. So they gave us this story to go along with this equation instead of just giving us the equation. Find the value of t for which the ball's height is 15. So I don't really need these right now. But I do want to use this equation here. So if I have h equals 5 plus 27t minus 16t squared, keep in mind it goes ax squared. So this is the a. And then bx, so this is my b, and this is my c. So it's backwards. I have to make sure I keep that in mind. And if I want to find all values of t for which the ball's height is 15, I need to be careful before I label this. This h actually needs to be 15 for me to be able to find this correctly. So I'm going to subtract 15 from both sides so that it equals 0. So I'm going to have 0 equals negative 10 plus 27t minus 16t squared. So now I have a, b, and c. And I can start plugging this in. So I have x equals negative b plus or minus b squared minus 4 times a times c divided by 2 times a. So be careful on this one because it's backwards, or it's written backwards at all from the way we're used to seeing it. So we want to make sure we grab a, b, and c correctly there. All right, so we have negative 27 plus or minus 27 squared, which is 729. Negative 4 times negative 16 gives us positive 64, times negative 10 again gives us negative 640, divided by 2 times 16, negative 16 gives me negative 32. And then under the squared sign there, I want to subtract 729 from 640. So I get negative 27 plus or minus the square root of 89 divided by negative 32. All right, so now we want to go to our calculator here so we can finish the rest. So we have negative 27 plus square root of 89. And again, I'm going to hit equals first, and then I'm going to divide by negative 32, just to make that a little bit easier on me in the calculator form. You can also put parentheses around the whole thing. That would also work the same. So here, I want to round off to 100th again. So this is an 8 right after the 100th, so it's going to be 55 seconds. I want to make sure I put the 0 in here. Oh, no comma. And then if I do need to add another one, I'm going to click OR. But first I'm going to check. OR. Oh, thought I needed to click after. Okay, so I'm going to go negative 27 minus the square root of 89 divided by negative 32. Boom. Okay, so this guy does work out correctly. So here's my 100th. So it would be 1.14 because I would round up again. So why are there 2? Well, if we think about a ball being thrown up in the sky, it's going to go up, 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 and then it's going to curve and it's going to come back down, right? And I know I'm drawing right over my equations here, but it's going to have a certain point at which it's 15 feet on this side, and then would have that same thing on the other side when it's coming back down. So there's actually 2 points at which it's 15 feet off the ground, or from its initial height. So we should be good to go on this guy. Yay! All right, so that was section 4 and 5, and I will see you in section 6.